Hey everybody, this is Dustin over at Geekmatics, and today we are going to go over an iPad Air that has no power and kind of how to diagnose these type of issues, all right? I think this is a really important point to hit on, because a lot of the times what I'll see is people saying, hey, the iPad doesn't turn on, so I tried to change the charging port and TriStar and it still doesn't turn on. Well, you guys are changing things for charging circuit when it's really not turning on at all. So that kind of drove me to make this video, and I'm actually going to do a video series. So on this iPad, I do know what's going on with it because I broke it. I intentionally did what I did to get it in this current state. I tried to make it so it will pass visual inspection, because we will go over that. But I'm not going to skip any of the diagnostic process. I'm going to start right as if I don't know what's going on and do everything that I do normally. All right, so let's go ahead and get started. All right, guys, so the first thing we're going to do is we're going to attempt to charge the device or apply power to the device. Now, the device history here is very important. So if the client says something about liquid or we see liquid, that's not going to be our first step. We'll go over that in a later video, okay? Now, I know the device history, obviously, so there's no liquid. All right, so we're going to go ahead and attempt to apply power. Now, I'm probably just going to bring you over to my iPhone camera so you guys can see my amp meter and what happens. All right, guys, as you see, I have the charger plugged in, and on my amp meter, it's drawing about 530, 540 milliamps, okay? So that's not exactly what we want to see. So I believe what happens is with new technicians is they see that there's a 540 milliamp draw and they think, okay, it's not charging properly, so I'll go ahead and replace charging port, I'll replace TriStar, and that's fine, but there's a better way to diagnose that, and that's what I'm going to show you here. So the next step is to take the board out of the housing and get a closer look at it, and then we'll go. So now that we have the board out of the housing, we're going to go ahead and do our visual inspection. Take that plate off, and we'll go ahead and switch you guys to the microscope camera. We'll go ahead and do our visual inspection and make sure we don't see any water, which again we shouldn't. Alright, everything looks pretty good. Alright, so I don't want to go too in, because then you'll physically see what I damaged, and I don't want it to be spoiled by visual inspection. So let's go ahead and get started. So the next step after the visual inspection passes is we're going to go ahead and put DC power supply onto the board. Now, the way we do this is a little different than iPhone. What we're going to do is we're going to connect little alligator clips, these things here, to a positive and negative pin, or I normally just do positive and then find ground somewhere else on the board and connect it that way. So if you don't know which side is positive and negative, there's a really easy way to find out. You're going to put your multimeter in either continuity or diode mode, and you're going to have one probe on that, something you know is ground, and then you're going to check the pins. So the first one here that's going to be your positive because it's not ground. And then the next one here, just to confirm, is ground, okay? So that's gonna be the negative, and that's gonna be the positive, all right? So what we'll do is we'll go ahead and turn off our DC power supply and connect these. So I'm gonna go ahead and connect this one here, maybe. No, maybe not. This might not long enough, so we're gonna go down here, and then we're gonna hit the positive pin. Now we're not gonna touch on the metal there, okay? Because if we do that, the metal, I'm not sure if you guys can see the metal in the battery connector, sorry, because then that will show us a short, okay? So we want to get accurate results. We're going to flip it, make sure we are on the positive pin and on ground. That's good to go. And now what we're going to do is we're going to go ahead and connect our DC power supply, or turn on our DC power supply. And just to show you what I get, go ahead and turn it on. And you'll see I get a full short to ground, okay? And so I don't care about this device, so I'm gonna keep it that way. You'll see here that it is pulling as much as I will allow it. If I disconnected this, I'm set to 4 volts and 2.5 amps. And if I go ahead and apply the power, it will take as much as I will give it. So that tells me it is a short to ground, all right?
Alright guys, so that current draw tells us a couple of things. Alright, the first thing it tells us is there's a short on the device. Alright, the device will not turn on right now no matter what I do. Okay, the second thing it tells us is where that short is. Okay, it tells us that that short is on what's called VCC main. Okay, and is exactly as it sounds. VCC main is a main power rail that runs through the device. Okay, what it does is without getting into the too complicated or all the details, is it feeds the power management chip, or the PMIC, and the PMIC will divide that voltages up into several smaller voltages to feed, let's say, the camera power, or so on. Okay, there's several different things. All right. Now, what a short is it's electricity going to ground when it shouldn't. Okay, the most common form of short is a capacitor failing. Okay, so if you take a capacitor and you take your multimeter, and in continuity mode you put one side of your multimeter on one side of the capacitor, the other side of your multimeter on the other side of the capacitor, you'll have OL, or open line. That is a sign of a working capacitor. Now, the way that fails is it becomes a wire, essentially, and you will have continuity across it. And that means the capacitor is failing most of the time. Sometimes they are designed to have continuity, so not always, but in this instance, that's what we have. Now, in order for a short to happen, the capacitor or the chip itself has to have a leg on ground. All right, so if you have a chip that has no ground underneath it, then it's impossible for that chip to be shorted. So if you have a short and there's no leg underneath it, or it doesn't have any connection to ground, then that is not going to be your issue, so you can move on. Now, there are several different ways to identify a short. Okay, I use 3 ways. I like to use freeze spray, rubbing alcohol, and thermal camera. Now, I'm not going to get into the thermal camera here because this video series is made for beginners, and a beginner is probably not going to have a $500 thermal camera that they can just bust out whenever they have a short. So I'm really going to be going over freeze spray and rubbing alcohol. Now, freeze spray is very expensive, but what I like to use is this stuff called Duster. I like this brand because it's close to my name. And all you have to do is tip this can upside down, and it immediately becomes freeze spray. Okay, so this is a lot cheaper than a can of freeze spray. Now, one thing that I like to mention is I would always wear gloves when you're dealing with this stuff, because it has a bitterant added to it, that where if you spray it on the board and then you touch the board and even kind of get near your mouth or anything like that, it's the worst taste. So I always wear gloves when dealing with this stuff. All right. So, well, let's go ahead and try to see if we can identify where this short is using freeze spray.
Okay, so now you guys can see the board. I do want to draw attention first so you guys can see how I'm injecting the power. I have my alligator clip on the battery connector right now. So let's go ahead and freeze up some of this board here. I'll flip my can over and kind of spray it just a little bit. Okay. And we will apply power, and look, something gets hot, so that must be our issue, right? It's this sucker here. So let's go ahead and see what ZXW has to say about it. Open her up here, and what was getting hot? This here, Q8104. It looks like a transistor. Now, if you remember what I said about how a component can have a short to ground, I said that it must have a leg on ground, right? But I don't see a leg on ground here, so I don't think that's going to be what the issue is. So one of the things that beginners ask a lot is, hey, I have a short on main and this transistor is getting hot, so this must be my issue, right? And the answer is no. The reason that gets hot is because it's connecting battery voltage to VCC main, and VCC main has a short, so it's consuming as much power as you'll give it through this little chip, so it will naturally get hot. It doesn't have a leg on ground, so it can't fail. It's constantly being blamed, and it's never to blame. I feel bad for the guy. Now, one thing that you can do to kind of bypass this is you can either inject voltage right into main using a multimeter probe, and that's what I personally like to do, or you can go ahead and take that sucker off and you can just run a wire, and that will also solve that getting hot, and you know, it will kind of show you where your actual fault is. Okay, so what I'm going to do is my first option, I'm just going to inject voltage with my multimeter. So let's go ahead and do that and then freeze the board and see. So we're going to go with the injecting voltage method. We need to go back to ZXW,
and figure out where exactly we can inject voltage. So I'm going to pick this big cap up here, this big capacitor C8141, and on the board this is what that looks like. Let's see if you guys, where's my tweezers? That one I'm kind of pointing at right here. This one, I'm going to go ahead and inject voltage there. Now you'll see this line here on the capacitor. That means that it does matter what direction this capacitor goes, unlike these other ones that don't have any kind of indication. You can put those either way. This does, so you must put it that way. So that line means that's the positive side. So that's where I'm going to go ahead and inject. Alright, so while I get my probes ready, I do want to hint on what voltage I'm going to be at. So I'm going to set my DC power supply to 4 volts. That's because that's normally what's on main or around there anyway. It's the voltage of a charged battery. Alright, so that's what I'm going to be injecting. Now if it's a different line, like let's say PP1V8, I would immediately turn it down to 1.8 volts because PP1V8 means 1.8 volts is what's supposed to be on that line. I don't want to overdo it. Okay, so let's go ahead and zoom out here all the way. Now you will see I took my alligator clip off my battery and connected it to my multimeter probe here. I'm going to apply some freeze spray. Make sure that's all nice and frosty. Now I like the freeze spray because it looks like a snowfield and the bad cap normally pops right out. So let's go ahead and apply that 4 volts. And look, it did, right there. You see that immediately this cap came to say, hey, I'm the reason at fault. Now let's go ahead and see that again. Kind of dry this up a little bit. And you can see where I tried to short it. I used that banging method and it looked pretty close to okay if we didn't zoom in on it too much. So we'll go ahead and freeze this up again. Alright, nice and frosty. Take our multimeter lead. Go ahead and inject that voltage and look, right away you can see that cap is bad. Okay, now let's see what this looks like. Let's see what this looks like with rubbing alcohol. So we'll dry this up again. And we're going to go ahead and apply just a little bit of rubbing alcohol here. And inject voltage again. Now you'll see it's drying faster than the rest. Now this isn't as obvious to me as the freeze spray is, so I like the freeze spray. That's the one I grab for in a pinch, and you'll see if I lay off the voltage it wets up again, apply voltage it's dry, so that's clearly going to be the short. Now what we're going to do is we're just going to pop that bad boy off. Okay, since it's right next to the PMIC or the power management unit, that's this guy here, we're not going to use hot air there, okay? We want to be very careful anytime we use hot air, especially around underfilled ICs like that, alright? Dry this up a little bit again. And I'm going to take my blade and just break this guy off maybe. Yeah, just like that. Okay. I'm going to go ahead and test the line now to make sure it's not short before I put any power to the device. So I will go ahead and put my multimeter in diode mode. And I'll check both sides of where the cap was sitting. So if you can hear my multimeter beep, that means it's ground. Okay, we'll go ahead and check the other pad. And we have 179, so that is no longer short, alright? Now I believe we can go ahead and dry the rest of this board off and apply power to it. Alright, so you'll see I have my DC power supply connected back up to the battery connector here, and apply power. You'll see 0 amps or 0 amp draw, 0 current, okay, and 4 volts. So this is what you would expect to see from a normal working device when it's just sitting here turned off. Okay, so I'm going to go ahead and prompt to boot to see if I get a normal boot option here. Let's see if I can do it without or while holding my phone, and we'll hold it for a second and we'll let go. Alright, and so that fluctuation, that's kind of what you would expect to see with an iPad that has no screen on it. Okay, that's an important piece because with screen it's going to draw a little bit more higher. It needs power for backlight. Okay, we'll let you guys see for a minute exactly what it's drawing. All right, so that's a normal boot. So what we'll go ahead and do is put this iPad back in the housing and see if it turns on. I have the iPad in the housing, sort of, just loosely connected here, along connected with my test screen. So what we'll do is we'll go ahead and connect the charger. Okay, and this is a test screen, or maybe it's a known good. I'm expecting to see, there we go. Battery logo showing that's charging. And you'll see that is now pulling what we would expect, over 2 amps. That's fantastic. So I would think that this device will turn on normally. Alrighty guys, so just a quick review. What we did was diagnose an iPad Air that had no signs of life whatsoever. Now yes, I did break it, but just to show you guys how to diagnose something like this. Now this process is the same as with an iPhone. So if you have an iPhone come in with no power, it's the same concept with that transistor, with the charging, all of that good stuff. So I really hope you guys learned something today. I think I'm going to make a video series about the different types of shorts and where they're located based off current draw. That way you guys can just look at your DCPS and see, DC power supply, and see maybe where that short is based off how much current the device is drawing from that, okay? And again, that's DC power supply, not the amp meter. The amp meter will only tell you how the device is charging, okay? It won't tell you anything other than that, all right? So have a good day and enjoy the rest of your weekend, guys.